On the first video about rationalizing the denominator, we left off with a couple practice problems. So now that you've completed the practice problems, let's compare your answers to mine. And I tried to use color coding here to help guide the different parts of this problem. So in problem number 1, we had the square root of 18 in our denominator. We needed to rationalize that denominator. So we're basically getting rid of the radical symbol in the denominator and then add it to a term that doesn't even have a denominator. So I'm going to start with this first term and I'm going to simplify that as far as I can. So I know that the square root of 18 simplifies to 3 times the square root of 2. So I'm going to start by doing that. Then I can actually reduce my fractions right here. So 3 over 3 becomes 1 over 1. So this simplifies to 1 over the square root of 2. And now I'm going to rationalize that denominator by multiplying the square root of 2 times the square root of 2. I have to do the same thing to the denominator, so I get the square root of 2 over 2. Do not worry if you didn't do those steps in the same order, as long as you got to the same spot. So some of you may have started by multiplying both the numerator and the denominator by the square root of 18, and that's fine. Then you end up simplifying the radical in the numerator, but it is perfectly okay whichever order you do that in. Now I'm going to look at my second term, which is the square root of 2. I don't have to do any simplifying there, but in order to be able to add it to the first term, I need it to have a common denominator of 2. So I'm going to multiply my numerator and my denominator by 2. I get 2 times the square root of 2 over 2. I'm taking that red term and that blue term, and I'm adding them together. I've got 2 of this number plus another 1 of that number, so that means I've got 3 of that number, and then my denominator just stays 2. Problem number 2, I'm going to follow a similar process. I'm going to first simplify this second term because it is the one that's a little bit more complicated. I'm going to do that in red. Then I'm going to take the first term and I'm going to give it a common denominator, and then I'm going to subtract them. And actually there's nothing I can do to subtract them, so I basically just put everything in the numerator over 10. I did not talk through this part of it, but I think at this point you probably have that down. Notice that I did start to, I always want to make sure, especially if I have a number that I can't right away tell that it has no perfect squares, I want to break it down into its factors and see if there's any perfect squares that I can pull out of there. All right, for the most difficult, challenging part of the day, we're going to look at a couple problems together, and then I'll give you a couple problems for you to practice, and then we're done with a lesson for today. These problems are the challenging problems because they have 2 terms in the denominator, and I have to simplify those to rationalize this term. So I can't just multiply times the square root of 5, because if I multiplied this term times the square root of 5, I would get rid of the square root symbol. But I'd also have to multiply the 3 times the square root of 5, and then I haven't accomplished anything because I still have a radical symbol in the denominator. So instead of just multiplying times the square root of 5, I'm going to multiply times something called the conjugate. Now, you actually have seen something like the conjugate before, and when I start working with it, you'll say, oh, that looks a little familiar. But initially it's going to be super confusing. So I would recommend that you watch me do all the way through these 2 problems, and then if you need to come back and review any of them, you can pause it as often as you'd like to make sure that you're understanding each piece of it. So when I'm multiplying by the conjugate, again, my goal is to get rid of the square root symbol in the denominator. But in order to do that, I'm going to have to multiply by something that has 2 terms. So I'm going to tell you what it is, and then I'm going to point out why it is familiar to us. So the conjugate of this expression, 3 plus the square root of 5, is 3 minus the square root of 5. And the reason why that is, I'm going to come over to the side here. I've got 3 plus the square root of 5 and 3 times the square root 3 minus the square root of 5. I'm going to multiply, I'm going to distribute or FOIL or whatever you want to call it. I'm going to multiply my first terms together and get 9. I'm going to multiply my inner terms and get 3 times the square root of 5. I'm going to multiply my outer terms and get minus 3 times the square root of 5. Plus 3 times the square root of 5 minus 3 times the square root of 5. And then I'm going to multiply my last terms and get minus 5, because the square root of 5 times the square root of 5 is 5, and I've got that negative. So this should look familiar because we've been working with this. Ooh, what just happened there? We've been working with this pattern when we've been multiplying binomials. So those middle two terms go away, and I'm left with 9 plus negative 5, which is simply 4. So I'm going to come back over here to this problem. I've identified the conjugate. Notice that it has the opposite sign of the original binomial. I've multiplied my first terms, my outer terms, my inner terms, and my last terms, and I ended up with simplifying that to be 4. If I multiply the denominator by that binomial, I also have to multiply the numerator times that binomial, so I've got 3 times 3 minus the square root of 5, and I'm multiplying that times 1. Anything multiplied times 1 is just itself, and so that problem is actually easy as far as conjugates go. So again, to highlight vocabulary, these two binomials are called conjugates. They have the same terms, but they have opposite signs, opposite operations. So this one is plus, and this one is minus. All right, let's try another one. I'm going to first identify the conjugate. So same terms, opposite operations. Whatever I do to the denominator, I'm going to do to the numerator. So I'm going to put that up here right away. Let's do the denominator first to make sure that I accomplish my task of getting rid of that radical symbol. So my first term is going to be 1. My inner terms are going to be 1 times the square root of 3, and then minus 1 times the square root of 3, which those are going to go away. And then my last terms are going to be minus the square root of 3 times the square root of 3 is 3. So that's going to simplify to negative 2. Now I'm going to take care of my numerator, and notice when I'm multiplying a binomial times a constant, that constant gets distributed to both terms. So 6 times 1 is 6, minus 6 times the square root of 3. So there's nothing I can do to simplify that any further, so I'm just going to write that down. Now I'm noticing, though, that these can be reduced. So I'm going to reduce 6 over negative 2. That reduces to negative 3. Negative 6 over negative 2 reduces to positive 3 times the square root of 3. I also could have, never mind, I'm not going to say what I was going to say about I also could have. So those are a couple examples of creating a conjugate to rationalize that denominator. So here come a couple problems for you to practice. Go ahead and pause it for as long as you need, and then come back and check your answers. All right, on the first problem, my conjugate, again, is going to be the exact same terms with the opposite operation, so it's the square root of 2 minus the square root of 7. Notice that in the denominator, when I multiply negative 2 times, square root of 2 times square root of 2, I'm going to get 2. Square root of 7 times square root of 7, I'm going to get 7. So that's going to be negative 5. Notice this as opposed to this. We're going to point this out when we get down to here. Then I'm going to multiply the 10 times both of those terms, and I get to this part, and I see that I can reduce this, and I can reduce this. So this is going to be negative 2 times the square root of 2 plus 2 times the square root of 7. So that is my final answer on that one. Number 2, the denominator is a little different because I have one radical and one that's not a radical. So I have to be really paying attention to that. My conjugate is set up the same way. I have the same two terms, but the opposite separation. Notice that the square root of 3 times the square root of 3 is 3. That this is 9 times 9 is 81. I often see students make this a 9. So we're so used to multiplying the square root of something times the square root of something that we don't pay attention when it's not a square root. So 9 times 9 is 81. So just be really careful with that. In the numerator, I'm multiplying both terms times the 39. Notice in this second term, I just wrote 39 times 9 because I'm pretty sure at the end I'm going to have to reduce, and there's no sense in multiplying that. I think it's 300 something. There's no sense in multiplying it when I'm going to have to turn around and reduce it. So I'm just going to leave it in this form for right now. 3 minus 81 is negative 78. And then I do recognize that 39 and 78 reduce to 1 over 2. So I'm happy that I just left this broken down into its factors. I'm going to reduce both of those, so I end up with this is 1/2 and this is 1/2. So I've got the square root of 3 plus 9 over negative 2. That's okay. You also could have put the negatives in the denominator, so it could also be negative 3 minus 9 all over positive 2. This is actually preferable to get that negative into the numerator instead of the denominator, but really at this point in our math progress, either one of these is fine. So again, rewatch that video as many times as you need to clarify those. You're going to have a couple more of them to do on your practice assignment after this, but these are tricky, so be patient with yourself, be kind to yourself, and you will get it, and hopefully you will have fun while you're doing it. Okay, email me or let me know if you have any questions. Bye.